Hello dudes, we're at the Things conference. Disruptive technology, that's what we bring you. So today, we are looking at a LoRaWAN sensor node using two old friends of ipXchange, EPs and Dracula Technologies. They've created this node which can give you everything that you need with only ambient light. Right, we are at Things in Amsterdam, as we discussed. What we're going to talk about is this LoRaWAN sensor node, two old friends from ipXchange, Bruno from EPs.
Hello, hi everyone. Yes.
Please.
So nice to meet you, everyone. We are here in the temple of LoRaWAN in Amsterdam, first day, first half day, and we are here to show how the combination of Dracula technology, electronic PVs or organic PVs, and EP's PMIC are perfectly fitting the LoRaWAN ecosystem. So we have plenty of...
So the first question for me is, if this didn't exist, how would you solve that problem?
So if
what's today's solution without EPs and Dracula coming together?
Yes, so today if you were to use a LoRaWAN product, you have to put batteries or wires to give it energy. Wires, you know the hassle it is to support cabling, how to get access to energy in some remote places, locations which are not very convenient. Cabling is costly. The other alternative is to use batteries, and a lot of products use batteries, but they are disposable. It's also another problem, a main problem for the industry, because they cost a lot. They have a finite life. They have usually a lifespan of 1 year, 2 years, and sometimes they get out of work, so they need to be replaced.
Yep.
Cost of replacement, cost of intervention is catastrophic for the total cost of ownership of a solution.
Yep.
It can be even a blocking point for deployment of solutions. So people and developers are continuously thinking of alternative to the disposable batteries.
Right, so you think there's a lot of audience out there, a lot of potential customers who would be using this kind of node if they knew that there was a solution that was batteryless, and they could use ambient light to connect to a network.
Absolutely, and this is a fact that we see during this show. We have a lot of people coming at us saying, okay, I have to replace the disposable batteries, or I have already started to think of replacing the batteries, but how to do? What do you advise me to do? How to do that? Do you have a solution?
So is this an off-the-shelf module that you make available?
Alors, this is an off-the-shelf evaluation kit that allows you to start playing with combinations of organic PV cells like we have here, combination of storage elements like we show here, and simulating an application, a LoRaWAN application with just a simple potentiometer. So all these combinations are possible. We have to...
And then there's that user interface at the same time?
Yes,
they can...
this user interface allows developers to play with the parameters and see what happens if I use a bigger photovoltaic cell, a smaller one with different shapes. I can also replace a storage element with various options, and I can also play with my little potentiometer to see how I can increase energy while keeping on charging. And while at a moment when I get too much of energy, I start to have not enough energy coming from here, but the job is...
It swaps to the battery source.
Absolutely, that's a rechargeable element that plays a role.
Right.
And that's really an important point, because energy harvesting is by constitution intermittent.
Yeah.
You have daylight alternance, you have high light level, low light level. Here we have a nice spot on us, which gives us a light level of about 600, and once this light spot is switching off, we have only half of it. And you have to adapt your system to these variable conditions. And that's the role of the PMIC. And you can see that once I have my system working, I can, in real time, measure that the system is harvesting, charging, and...
So if we just show that, what's going on here is I've covered up PV cell. So automatically it's censored the fact that it's not getting its power from the ambient light, and it's automatically gone to the battery life. And then when I take it off, it then switches.
Yes.
Clever stuff.
And this stuff, this information that is available in the PMIC can be used by the LoRaWAN application to push back information to the cloud to say, I am healthy, I am okay, I am running out of light, or there is a condition of night or day, and the cloud can instantiate a lot of value added services to the end user.
Yeah.
To do maintenance, to do observation of energy production, consumption, whether the system is on or off. Remotely, you hardly know when your system does not communicate anymore. You hardly know if there is a reason due to energy source, due to connectivity.
Okay.
With this type of system, you can do it. And just to highlight that this EVK is, let's say, a 10 times bigger PCB to allow configuration. You have a lot of jumpers.
Yeah, it's not actually going to be that size when you put the sensor in the field.
Of course.
No.
The area of the usable part is less than the finger nail.
Right, very good. Well, Bruno, thank you for that introduction. So we're going to now go over to Jerome, who's going to tell us all about his Dracula technology, which is some of the power source to power this node. Hello, Jerome. So we've had an introduction about the technology. We've understood what this sensor's doing, where it can go, but then you've got this very interesting solution as to how it's getting its ambient light and then that keeps it up to date and sending data to the cloud. So just tell us a little bit about how this works with that and why that is different to any other potential power source that this sensor could work from.
Right. Thanks, Guy, for asking this. So basically, the way it's working, we do OPV. OPV stands for organic photovoltaic. The benefit of OPV is generate energy from ambient light.
Yep.
Indoor use, which is completely different from traditional solar. It's where we're the most efficient. Now, related to how does it work? When you have energy harvesting solution, you need three components. You need a harvester, in our case, which is the light harvester, ambient light. You need a storage element, and you need a PMIC. The PMIC will take a perfect triangle. That means you have the great harvester with the bad storage or bad PMIC, you will lose the benefit. Same thing if you have the bad harvester and everything's good, it's not working properly. So once we're able to determine what will be the right application needs, we'll customize the PV.
Right.
For example,
that's an important point, is the customization of his technology. It's not just an off-the-shelf. He can work with the potential customer to work out what's the best way to use this application. Really unusual approach.
Yes, basically, if I just summarize Dracula in a sentence, our standard is custom.
Yeah.
That means the way we do. It's made by inkjet printing, all the shape and so on. So, and also because we want to reduce to the minimum the energy consumption and the raw material consumption. Even if everything is organic, no discussion about no rare earths, no heavy metals for sure. But if we can make 12 centimeters square instead of 20, we'll make 12.
Right.
That's really important. So once we have determined what the best answer, after it's just a matter about setting and fitting for the customer product. So we can after go into the shape. First we speak about the technical feature, what the voltage I need, how much current, what kind of PMIC, what my storage element size, and later on, okay, now will it be round product, will it be whatever. That's for example, if I take that PV, we do that shape, because at the end the product will be this.
So you've wrapped the PV around the product.
That's it.
You've wrapped the PV around the sensor.
Exactly, because we produce for manufacturing, we print it flat. Oops, we print it flat like this, and after we just wrap it, and it's on its go. And you can last 8 to 10 years indoor use as a minimum.
Yeah.
With let's say 80% efficiency still available.
Yeah. So just tell us a little bit about this whole idea of being organic.
No, it's important for us to be organic for two reasons. Organic because it's no rare earths, no heavy metals, and also because for the main application we want to tag, it's mostly indoor use, indoor application, and in that case the organic is much more efficient compared to traditional solar. My product will not be good at all if you put me in the sun outdoor. I will not be the best answer. But if you use me in indoor light like this, I will be one of the best options.
What's the name?
What's the name? Because Dracula. Because we don't like that much the sun and the
sunlight.
That's it.
Very good, very good. So we just, I just showed the demo how when I cover that up, it kicked in, went to the battery source, and so you can see how the actual sensor node is running completely from the Dracula technology to get its energy source and keep it giving information to the cloud.
That's it.
Very good.
Okay.
Okay. Thank you. Excellent.
Thanks a lot. Thanks.
Hey, yo, where my engineers at?